dialogue shaping. So a little bit of background first. Reinforcement learning always has demonstrated remarkable effectiveness in solving intricate decision-making tasks, but its trial and error approach often leads to slow convergence to the optimal policy, especially when the action space is very huge, like the text adventure games. And in those games, there are always non-player characters or NPCs that possess crucial game information that could spare the agent from extensive trial and error. And by utilizing this prior knowledge, we can significantly reduce the agent's policy space. And so that's the intuition for our dialogue shaping approach. We essentially, by using this approach, we essentially break down the end goals into smaller tasks. So for example, if the agents know that kill the dragon requires a sword, then it is able to concentrate on first figuring out how to find a sword first instead of wasting time figuring out how to kill the dragon. So our dialogue shaping approach is able to first extract those useful prior knowledge through conversation with the NPCs. Then it will convert that information into knowledge graphs, which will be used in our agent's training. And finally, we'll add extra reward signals to the game. So here is one of our game maps. And as you can see, the end goal of the agent is to kill the dragon, and in order to do that, it needs to first complete two prerequisites. The first one is it needs to go to the castle, and the second one is it needs to get the sword, which is located in the castle. So the first step is how can we ask the right questions to the NPC and in order to get the useful game information. So naturally, we have to first prompt a ChatGPT to act like the NPC, which will be responsible for answering questions. And we will give NPC all the game information, so like the layouts, the goal and prerequisites, as well as the object locations. Then we will also prompt another ChatGPT to act like the agent, which will be responsible for coming up with questions. And we also give it a few instructions on how to come up with the most relevant questions. Then we proceed to the dialogue, where at each step, the agent will ask a bunch of questions and the NPC will give responses based on the game information. And then based on the responses from the NPC, the agent will pick one previous question and ask its follow-up questions. And so in this case, we can see that the agent successfully retrieves the two prerequisites in order to reach the end goal, which is get the sword and also go into the castle. And then the next step is we will convert this information into the knowledge graphs. And we do this by prompting the agent ChatGPT to generate the knowledge graphs. And as we can see here, the ChatGPT agent generate a knowledge graph comprised of two edges, which corresponds to the two prerequisites. And then finally, now we can train the RL agent. And at each step, the story shaping technique will essentially generate the current KG for the agent, which represents the agent's current state. And then it will calculate the similarity score between the agent's current KG and the target KG, which is the one generated at the previous steps. And then based on this similarity score, we will give extra reward signals to the agents. So in this example, the current state of the agent contains every edge in the target KG. So in this case, we'll give maximum extra reward signals to the agent because essentially we want to encourage the agent to complete the prerequisite first. And we evaluate our approach by training the RL agent throughout 100,000 training steps for each game. And for every 50 training steps, we will also let the RL agent play a few episodes, and we will keep track of the average scores that it obtained. And the blue line here represents the RL agent with the assistance from dialogue shaping, and the red line represents the baseline RL agent, which is just playing RL with only that one reward signal. And we can see that the story the agent with the help from dialogue shaping is able to converge much faster than the baseline and much more consistently as well.